Well, as I mentioned, there is not a linear step-by-step procedure that we can use to complete these proofs, like we did for that last step, starting with the last step and asking what has to be done prior to that. There isn't any, not that I'm aware of. And it's because there are so many possibilities given these 10 rules of replacement. But that doesn't mean there's nothing to do. There still are a handful of strategies to apply to complete these proofs. And the first and best one, it's best because it's most successful. It also happens to be the one that's used in, I would say, easily 9 out of 10 cases. And that involves your ability to recognize what resembles one of our first 9 rules of inference. It could either be a premise and a conclusion, or all premises and conclusion of, for example, modus ponens or modus tollens or hypothetical syllogism. And I say resemble because it will have to be manipulated by replacement to make it count as a substitution instance of, for example, hypothetical syllogism. Now, you're using this particular strategy requires that you be real familiar with the first 9 rules, which you should be by now. You need to be able to recognize them on sight. Whereas before, we were insisting they have to look exactly like this. See, now we're turning the tables a little bit and say they don't have to look exactly like that. If there's a resemblance there of one of the first 9 rules, then the way to the proof is to manipulate, to change the appearance of that resemblance so it does fit exactly, for example, hypothetical syllogism. And I think you're going to find that we encounter this many, many times tonight when we start our proofs. That's the best and most common strategy. Number 2 is similar to something that we did before with our 9 rules of inference. That is, remember, we looked at our premises and asked, what can I use these for? What can I do with them? You still should go through that preliminary procedure. We don't have time to do that right now. I'm going to trust you to notice what you can use your premises for. What we're going to do, you and I in class, is to instead note any obvious replacement statements in our premises. And by obvious, I mean spot-on substitutions of distribution or material implication or association or commutation. Because if they're there, most likely they are going to be replaced. It's not a coincidence that they're there. Now, sometimes the conclusion itself is a replacement statement. So it would have replaced the immediately prior step of the proof. Do you understand what I'm explaining? Okay, when that's the case, the proof can be very difficult because our aim has always been to derive the conclusion. But when you've got a proof like that, the aim is to derive the immediately preceding step to that conclusion and then replace it. Well, how do you know what that would be? If the conclusion is an obvious replacement statement, then we can determine what it replaced, okay? And that will be the goal of our proof, to derive that second to the last step and then just substitute the conclusion for it. Now we're getting down to desperation strategies. And I think this is the only one that your author suggests. This is the only helpful tip that he gives you. It's certainly not enough, but it can be very useful. So I think you could imagine the simple statements, the letters, the uppercase letters, right? If some of them occur in the premises, but not in the conclusion, then obviously they need to be eliminated somehow. Okay? Now, how do you eliminate them? Well, it turns out that our extraction rules in the first 9, simplification, disjunctive syllogism, modus ponens, we were calling those extraction rules. And they are. And we're still going to consider them to be that. But at the same time that you're extracting a component from a dot by simplification, right, the left-hand conjunct, we can look at it another way now. We're leaving behind or getting rid of the right-hand conjunct. Can you imagine that without me putting it on the board? Yeah, simplification. P dot Q, therefore P. So previously we were saying we want to extract that left-hand conjunct from a dot. That's all good, we still do. But we also need to consider at the same time we're extracting that left-hand conjunct, we're leaving behind or getting rid of the right-hand conjunct from our proof. So if we recognize that at least that has to be done, that can get us very far in our proof procedure. It's a good strategy. Number 5, now we're really getting down to desperation. These proofs can be very difficult, very challenging. When we've exhausted all those strategies, you don't just do nothing, you don't give up. You can start replacing statements or components off to the side. And look at what I call the expanded argument. You're looking at it in different forms, having been manipulated before you even start the proof. See, if you have those additional statements to look at that have been manipulated by replacement, then something might catch your eye and one of the preceding 4 strategies can be used. And finally, number 6 is not a strategy. There's always something to do. And so when we do these in class tonight, next week, the following week, I'm going to alert you to these strategies. That's what I want you to practice. And again, this document is on Moodle. I suggest, if you can't just remember these 5 strategies, print it out. Have it handy. I'll even let you use that on the fly. Okay, are there questions about my explanations of these strategies? Yes?
So we're solving them, rather than using retrograde reasoning, we're solving them from the 3rd step to the 4th to the 5th.
That's not even necessarily so.
Okay. I see.
It's more the sequence is more random.
Like you said, we could use retrograde reasoning in that one case.
What one case? Not
where we know that the.
Oh, but that's only in the last 2 steps.
Yeah.
Yeah, if it's like a 5-step proof, well, that'll give you the second to last step.
Yeah, then it can
But
start
it
up
can't
all the way
complete
to
the
one.
proof for you.
He'd be all over the place on a 5-step. Pull it out, push it over, take a look at it, retreat.
Oh, I think I have to adjust this. Well, I'm going to count on this. See if I'm in the picture. Okay, 2-step proofs in the 14th edition. This begins on, let's see, page 373. 373. Now, the first few of these don't really employ our strategies. It's just a matter of our making some logical considerations on how we can derive that conclusion from the premise. But very shortly, after about 3 or 4 of them, then our strategies are going to be involved. This is number 1. A little lower next time. Well, you could probably spend a lot of time trying to get curl A from that premise, but I'm going to save you some time because we need to get on with this, and you might remember what I'm pointing out here. You might say that I'm going to extract curl A from that premise by modus ponens. I could see you considering that, right? The second premise would have to be A. Agreed? Now, we still cannot get the antecedent out of a horseshoe, even with the addition of these 10 rules. All 19 rules can never extract the antecedent from a horseshoe. So A is never going to happen, therefore modus ponens is never going to happen, and curl A is simply not coming out of that consequent position. It's not. So now we might ask, well, what can I do with this horseshoe, either with the first 9 rules or the next 10 rules? Well, with one horseshoe, the only thing you could do is absorption, given our first 9 rules. If you replace that by absorption, it's not going to get you closer to curl A. So I would turn to the 10 rules of replacement and ask, well, okay, I have a horseshoe. What can I do with it? There are 3 things we can do with the horseshoe. We can replace it by material implication. Let's just go off to the side here and see. Oops, that's not the one I want to do first. We can replace it by transposition, right? And if we were to replace that by transposition, I hope you agree, that would be the replacement statement. That doesn't seem to be getting us anywhere. I would still probably say, well, can I extract curl A from that horseshoe now? No, because that's the same thing as A by double negation, and we know we can't get that. You can replace that by exportation, but this is not subject to that. It's not a substitution instance of either of those horseshoes in exportation, right? It's not complex enough. That leaves us with material implication. That's what it boils down to. We have to try it. So, and by the way, this is the correct step. So why don't you go ahead and replace line 1 by material implication and see what you come up with. You're going to turn that horseshoe into a wedge and negate that antecedent, which would be the left-hand disjunct. Okay. Do you have that? What does it look like? Good. Now at that point, and does it have to be like, do I expect it tonight? No, but sooner or later, and we hope sooner, you need to be able to spot examples of your replacement statements, and that's a real easy one. That's tautology. So everybody pause to verify that that's a replacement statement of tautology, right? Okay, so what do we replace this with? Our conclusion, curl A. Verify that. What does our notation look like? 1, implication, material implication, and then 2, tautology. Well, maybe we should run down Maybe we should go through our considerations here. I wonder, maybe we're extracting curl A from the consequent position of a horseshoe. We determined that's not going to happen by modus ponens because of the impossibility of deriving A. So then we turned to our rules of replacement and asked, what can I do with a horseshoe? We looked at tautology. That didn't appear to get us any closer to curl A. In fact, I would say farther away. We noticed that it doesn't count as an exportation statement, and that left us with material implication. So we had to look to see, what does it look like if I replace line 1 by material implication? And at that point, you've got to recognize that's just tautology. It becomes curl A. Good? By the way, the notation for our new rules, our 10 rules of replacement, even though it's obviously always going to be one number, right? Because you're only you're only performing replacement on one line at a time. Agreed? Okay, now, so we can replace either an entire line or a component of a line. We went through that earlier, correct? Your numbering doesn't change. If you replace all of line 1, it's simply 1. In this case, implication. If I replaced a piece of line 1, it's just line 1. In other words, we don't have any way of indicating whether we replace an entire line or part of a line. It's just not within the means of our notation. You just refer to the line that was operated on and then the rule of replacement. Okay, questions about that one? Then number 2. Okay, this doesn't really involve any of our strategies, I suppose, except with 4 or 5, just start replacing something. Rather, our proving this, our proof depends on our recognizing what we have to work with here. You should notice that both the premise and the conclusion, it's a pair of dots. No difference there. You should also notice that the exact same simple statements occur in the premise as in the conclusion. B, C, and D. Then I suppose we should say it's just a matter of rearranging things. That's all. I just have to rearrange things. So if you remember when we introduced commutation and association, I said, so I hope you jotted it down. They're often used together, one at a time, of course. They're often used together to drastically alter the appearance of dots or wedges. And that's what you're going to do here. You're going to use some combination of commutation and association to alter the appearance of that premise to make it appear like our conclusion. Because they absolutely mean the same thing as they said. Well, we'll notice that 2 things have to occur. Our parentheses are around the wrong 2 disjuncts. In the premise, they're around C and D. We want them to be around D and B. But look, the only thing you could do with association right now is move those parentheses from C.D to B.C. And that's not what we want. So I don't think you're going to do association first. What can we do with commutation? Let me point out what you can do with commutation. I can commute C and D as a component of this premise. Do you agree?
Yeah.
But I can also commute B with C.D. Do you agree? Okay. Well, I think that's going to get our letters at least in the right order, isn't it? Okay. So we can't do anything with association right now, but we can get our letters in the right order with commutation. So that's what we want to do. All right. Do that. You should have this. Yes? And now it's simply a matter of moving our punctuation, our parentheses, around the correct or the conjuncts that we want them to be around. Agreed? Okay. There we go. That's our conclusion. And it's to association. Good to go? All right. Now, number 3 is an interesting combination of something I hope you remember from our practice for the last test. And then we will use one of our strategies from tonight. Well, all we have to work with as a premise is E. And we've got a rather complex conclusion to be derived from that. One thing you should notice is that our conclusion contains simple statements, or in other words, letters that don't exist anywhere in the premises. Does anybody remember the only way to introduce statements into the proof when they don't exist in the premises? Does anybody remember how the only way that can be done? Addition, thank you. You guys remember that? Because addition says, from any premise whatsoever, you can conclude the disjunction of that premise and whatever you want. So that includes statements that don't even exist in the argument. So we know that one of these 2 steps is going to be addition, don't we? Okay. The second thing I would like you to do, and this has got to, you need to, however you want to become familiar with identifying these replacement statements, I'm telling you, you've got to become familiar with them. It doesn't matter that I'm giving you the paper on the test. This is what we call an obvious replacement statement. It's an exact substitution instance of one of our statements in the rules of replacement. So I'd like you to find it, verify that. What's that? That is a statement of distribution. Everybody recognize that? Okay, so now we have a third strategy to employ. Since the conclusion is an obvious replacement statement, maybe it's replacing whatever disjunction is in line 2. So I'm going to assume that you don't know exactly what your addition has to look like for line 2. Let's take this approach. If this is in fact replacing its logically equivalent statement by distribution, what would that look like? So I'd like you to figure that out and jot it, because it is, by the way, that's what's happening. So figure out what that would replace. I mean, this is obviously the last step of our proof. I'm going to go ahead and write that in. Question is, what does its distribution replacement statement look like? And I think you'll find that is the wedge we want to produce by addition. Is it? Okay. Read it off for me.
E and dots?
No.
No. No.
Go. It's not a dot, it's a wedge. Figure it out. Remember, distribution, wedges and dots are interchanged. So this dot right here, that becomes a wedge. Anybody else have it? What does it look like?
E wedge, parentheses, F, dot, J, or G, sorry.
Okay, so is this in fact distribution? Can we do, I'm sorry, addition? Does that count as this? Yeah, it sure does. It sure does. So let's quickly review our strategy here. I think the first thing in this case you need to notice is that there are some simple statements in the conclusion that do not exist in the premise. And we've said before, leading up to the last test, there's only one way to introduce statements into a proof when they don't exist in the premises, and that's addition. So we knew that one of our two steps was addition. Then we recognized the conclusion as an obvious replacement statement of distribution. Since it was obvious, we supposed, well, that last step is probably a replacement of line 2. So we found out what the replacement statement of the conclusion would look like, and that told us what our conclusion of addition must be. And let's put our notation in here. It's line 1, addition, and then 2, distribution. Good? Questions about that proof? This would be number 4. Okay, this is, of the few we've done so far, this is the first occurrence of one of our strategies in that list I showed you. I think it's 4. What did we say? What was 4th on the list? That's right. We have a case of a simple statement J that exists in the only premise of the argument, and it doesn't exist in the conclusion. So right now, the one thing we know is that J has got to go. It's got to go. And how do we get rid of statements? By what we previously called extraction rules. Simplification, disjunctive syllogism, modus ponens. The second thing we need to notice, and again, this has to come pretty quickly for you. This is an obvious replacement statement. It is a spot-on substitution for one of our rules. It's important to recognize that, because when you've got something that's spot on, it's going to be replaced. That's why it's there. So I want you to glance over your chart or your rules and find out what exactly is that an example of. Of what? That is a distribution statement, isn't it? Well, it might not be clear to you what the proof is right now, but since that is an obvious distribution statement, I'd have a look at it. Have a look at it. See if it helps derive the conclusion, and I think it's going to. Oh. Okay. Have you got that replacement statement worked out? I think you should have H, wedge I, ooh, that's looking good. Dot, H, wedge J. Nice. Now we have our conclusion on the left-hand side of a dot. And I think you know what to do with it, don't you? What do we want to do with it? Simplify. Get rid of those parentheses too. Good? You're getting warmed up to this? Shall I erase that? I shall. Number 6. Well, there are two things I would notice about this. That premise, again, it's an obvious replacement statement. So you need to find, and it's a horseshoe, so look, huh? Okay, check out exportation. You'll find that that's replaceable by exportation. I'm not saying it is going to happen, but it could. As a matter of fact, I can tell you right now that that's not going to happen, but that doesn't mean it's not important to identify that. But see, you might work on that for a while and find this is not going anywhere. I'm saving you some time. So we should notice something else. That premise and that conclusion resemble the premise and conclusion of one of our first 9 rules of inference. Resemble it. They're not exact, but they resemble it. First 9 rules. It's got one premise and a conclusion, and obviously they're both horseshoes.
Absorption.
So, huh?
With absorption?
Yeah, it strongly resembles absorption, right? P horseshoe Q. P horseshoe, it's supposed to be P dot Q, and it's not that, but it's real close. But remember, our 10 rules of replacement allow us to drastically alter the way things appear. So if I were you, I'd go ahead and experiment and see what the conclusion would be by absorption from this premise. Have a look at it and see if we can manipulate it to create our conclusion, the ultimate conclusion. And by the way, this is what's going to happen, so if I were you, I'd go ahead and do it. Draw a conclusion from line 1 by absorption. Have a look at it. Does it look good?
Immediately.
Huh?
I think you can recognize it immediately once you do it.
Yeah, I know, that's the goal. Sometimes you just have to try something that's suggested, have a look at it, and then you've got to rely on your familiarity with the rules. There's no substitute for that. Let's see what our conclusion by absorption would look like. I think it would be N dot O horseshoe bracket N dot O dot P bracket. Did I do that correctly? Is that the conclusion of line 1 by absorption? Yes, no, maybe? Probably not even in the screen over. Absorption is? ABS? Nice. You can move everything over though, huh?
Just a hair, yeah. We're getting longer.
Okay, so again, he said, once you do that, you immediately recognize how to manipulate that consequent. So here we're just gonna operate on a piece of a line, which is perfectly fine. See, the only problem is that the parentheses are around the wrong two letters. Letters involved in dots. And we sure know how to move them, don't we? It's association, right? So it's just line 2, even though we're operating on just a part of a line. Good?
That's close.
We're cruising. This is number 7. Is that in the picture?
Down,
Yeah?
a little bit down.
Down?
Yeah, good. Yeah. Speak.
It's on there?